Okay, hi. I am back, and you found out I was lying and I didn't know what I was talking about. I decided not to do that previous page that we were looking at where it said introductions, and this should be your front page, so I hope you figured that out. If I was smart, I put a sticky note on it for you to explain that. All right, so we're going to be talking about writing systems of equations. Kids, do you remember what systems meant? What that meant? We have equations, and it tells us a specific number. Okay, so this systems, and you guys are writing on this. You've got your pencil. You have got maybe, hopefully, your calculator's still out, your yellow flip book, highlighters, everything that we use to take notes, old school method. Okay, so that systems tells us that it is going to involve two equations. And I know we love writing equations so much that we're just jumping for joy now that all of these we get to do two at a time instead of just one. Yay! Okay, just kidding, I know. It's all right, we're going to be fine at this, okay? It's going to be good. All right, so vocab, linear equation. I know I just said a system is for two equations, but let's write everything we know about them. So what do you know about linear equations? I'm going to bet the first thing somebody is saying or thinking. I'll be quiet for a second so you can say or think. Okay, I'm going to count to 5 in my head whenever I do that, so you kind of know that you've got about 5 seconds before I start talking again. I hope somebody said that it has got a constant. My pen is too big. I got to change this. Constant rate of change. Okay. What else do we know about linear equations? Going to count to 5 again. Okay, I hope you said that when we graph it, it's a straight line. That'd be pretty cool if you guys really did say that. It'd be like you could read my mind. Okay. What else do we know about the two equations? I have a set of notes done here, so I'm going to look at it. So remember, I'm going to count to 5 again so you can think of something else you know about them. Got to get to it, sorry. Okay, here we go. I don't know what you're saying because I'm not there, but let me ask this. What formula do we use for linear equations? What is the ones we use? Hopefully, you're saying y equals mx plus b, and I want to put boxes around our m and our b for when we have a per amount and a starting amount. What is the formula that we use when we don't have one per amount and a starting amount? What's the one we just used in our bell work for when there are two per amounts? I hope you say standard form. So that's our AX plus BY equals C. And our boxes that we need to fill in when we use this formula are the A, B, and C. Okay, and remember, I have no idea why they chose capital A, capital B, capital C, but that's what it looks like. Okay, so the next part we're looking at is the systems. So our systems means that there's going to be the two equations. Oh, look at that, my pen color changed. Interesting. Okay, that's all right. Okay, so we're going to have two equations. Why? Why do we have to have two equations? Well, do you remember the story I told about my alarm system that I truly did use two equations to figure out which company would end up being the cheaper in the end? So I had to write the two equations. So what these two equations are going to do, in whatever the situation is, it's going to compare two, for lack of a better word, things. It can be people, it can be companies, it can be food, it can be money, it can be all kinds of stuff. Time. Usually, my other screen. Okay, you guys should see me. I'm sitting here on my couch. I have got 4, 5 things around me. I have got my laptop, my school iPad, and my iPad so that I can sit here and have all of this in front of me. I am such a nerd. Okay. Or a dork. Maybe just a dork. 7th period, you get that. Okay. So compare two things. And the two things that they usually are going to compare is money. Will usually always be a part of it. Not 100% of the time, but usually always. And the second thing will be something that can be counted, like a quantity of something. That quantity, it could be time. It could be number of, I think the problem we're going to deal with is talking about number of tickets that you buy for something. So I'm going to say tickets. It could be the number of brownies and cupcakes sold. So it could be pretty much number of anything, but it's going to be a quantity, and I'm going to get my highlighter. And so quantity means that you can quantify, which means you can count, okay? So remember these two things. Let's go ahead and while we're highlighting, highlight money. Okay, did anybody see that mistake? Quantity, how about quantity? There we go, I fixed it. Okay, so I'm going to give us a few extra seconds, but because before I can move the page down, let's see, can I move it? Oh, no. Before I move the page down, I have to get out of the writing mode, which it'll erase it. So I'm going to erase now. Okay, and scoot it down. Oh, no, what? I don't know what's going on. Yeah, save. Okay, don't know what happened there. I think we're all good, though. Still recording. All right, so come down here. Up to this point, it says you've been writing and solving single equations. So now we'll be writing and solving two equations at the same time. So our goal here, let's highlight this. It's pretty important. Our goal, don't mark it out. Sorry. Highlighter. Our goal is to find a single solution that fits both equations. Okay, so if I spend a certain amount of money, how much did I buy of two different things? Okay, so money and usually quantities. Okay, so it says, number 1, write and solve an equation for each situation. So Nina purchased 4 pounds of strawberries for a total of $6.40. How much did she pay for 1 pound of strawberries? So first off, to write this equation, we need to identify what kind of equation is it? Okay, is it a 2 per amount or is it only a 1 per amount? Okay, this one, hopefully you're saying that it is a 1 per amount because on this one it gives us the total, that's the first thing, and then it gives us 4 pounds of strawberries. Okay, so how can we write an equation from that? Okay, I'm saying we're going to write, let me change my marker, sorry. Go back to the pen here. 4 pounds of strawberries. Now, this 4, it's 4 pounds, and we don't know how much they cost, right? So we can put 4p for pounds, or we could put 4d for 4, not dollars, but like 4, let's just put 4p. Let's not make this too difficult. I'm making it too hard. Okay, so 4p equals $6.40. And we want to know if she paid a total of $6.40 and each pound is going to be the equal amount, like, the same price per pound. We want to find that. So we're finding the slope, right? So to solve this, we're going to divide by 4 to each side, just a little one-step equation. Let me get my calculator. While I'm calculating, you guys calculate as well. Divide it up. And I get 1.6. Okay, and so this 1.6, what is it? Is it pounds? Bananas? No, hopefully you're saying dollars because we were finding the price. So this is $1.60 per pound. All right, the second equation is 5 pounds of apples for a total of $9.95. Okay, so take a second, write that equation. What do you think it's going to be? Okay, hopefully it looks just like the top equation. 5p equals a total of $9.95. Okay, solve it. Divide by 5 to each side. Go ahead. Okay, so how much were the apples? $1.99. That's what I got. Hope I'm right. Okay, so these were two little simple equations, and it says on here, we're going to take these same skills that we used to write and solve these equations to write and solve systems.